Hi everyone, thank you for joining us today. We are honored to have our own Associate Director at CCOM and of course a research professor, the person of Dr. Brian Calder, to give a presentation today. And we'll be talking about how you two come up the ocean. And we all know Brian, but his bio is also relatively short, so I'm just going to take the time to read it. Brian started in electronic engineering, but joined CCOM in 2000 and quickly saw the light, building data processing systems for bathymetric data and for estimation and for the estimation and use of uncertainty in all of its many forms along the way. He has spent a lot of time at sea over the years, much of it in the Arctic and the Victoria Pacific, but sadly still gets seasick on every trip. Please join me in welcoming Brian.
I'm a little concerned I may have to walk uphill this way. It's so unbalanced in the room. I think it's going to tip. Right yourselves a little bit of us. Good afternoon. Thank you, Liz. That's great. I'm going to talk about a topic that's started off as a passion project during COVID, actually, and has become a thing of its own. Kind of a fun sort of thing. It took me back to my roots as an electrical engineer as well, which is also kind of fun. And that idea is, what do we do if we collect volunteer data that we now own, so we have to do something with it, but we didn't have anything to do with collecting it? How do we control for it? How do we manage the level of uncertainty? What can we use it for? And so on. The generic term for doing this is crowdsourced bathymetry. I'm not a particularly big fan of the term, to be honest, because in many cases there isn't a crowd. By way of look at this. This is data from Puget Sound, from the public archive. This is typically what you see when people talk about this, and this is just the points of where the ship was when the observations were being made. There's a visualization question here. There's only so small you can make a point and make it appear on screen. So if you zoom out far enough, it looks like we've covered massive areas of the area here, because the pixels are now huge. If instead you look at data density, which is this one, and this is logarithmic data density, you can see that even in the areas that looks like we have lots of data here, but by that plot, obviously there's not really an awful lot. A big chunk in the center, that's the ferries coming out of Seattle going across the Sound to the other side. But even there's not really an awful lot elsewhere. So this is misrepresenting how much data you actually have. Majority of the time, your data density is quite low, and in many areas there just is none. So the idea of a crowdsourced is that if I ask the same question often enough, even if some of the people who answer are wrong, on average, I'll still get the right answer. But if the answer here is, well, how deep is it? What's depth? I really don't have too many people I can go back to and ask them, the same question at the same point in space all the time. Now, in areas where you have compactions, if you have like a methane channel, for example, or you have a navigation scheme or a river mouth or a harbour, yes, you can get to some sort of density of it, but it's not trivial to get it everywhere. Even if you go to closer in, so this is the area now just around Seattle. This is the primary dock at Seattle. You can see the ferries going across. This is Bainbridge Island, I think. In this area, LB. Even there aren't actually that many observers. All of that data is 19 observers. And the vast majority of it come from two different observers. One of them is a houseboat who just never turned their GPS on. And all of them have errors. If you compare their depths against the reference data, see the reference here is in red and blue is the depth from the observations there. They all have shifts. Those shifts vary as a function of depth and vary as a function of observer and even vary by observer over time as well. So there are lots of questions here about how do we handle that data? How much can we get out of that data? Do we actually have a crowd? What does that mean? There we go. But there are areas where this may be your only data. And that's when it becomes important to us. Those of you who live on the CCOM side of the fence here will have seen a whole bunch of people running around yesterday, or last week rather. That was an actual working group talking about volunteer or crowdsourced bathymetry. One of the presentations which I've cribbed here came from the Kiribati Hydrographic Service. And this infographic just points out just how much of a problem they have. They have very little data, and they're fairly resource strapped to get more. And it's really important to them because they live on lots of little islands. And so for them, any sort of data that they can get, even data, trackline data like this, is super important. And in many areas, that may be the only data they're ever going to get. And you don't actually have to go too very far for that to be true. This is America. Specifically, the west coast of Alaska and the Bering Sea. This is data, again, came from Anthony Clement and NOAA. This is the data from the archive against the best estimate of where things were at the time. As you can see, the boats are going on dry land. Very certain that's not true. This is a place where the sediments change frequently. And so where they're actually going is not anywhere even close to what's charted. And in many cases, there just is no chart in this area. If you look anywhere in like Glacier Bay, for example, the big cruise ships that go into Glacier Bay now go up to the glacier face so they can, tourists can see the calving of the glacier, see all the big icebergs. Where they're parked, last time it was surveyed, was glacier. And so that's a problem. So there's a value in this sort of data, even if it has problems, and it does, and we'll talk about them. There's value in this data if you can get it, if you can archive it, if you can then mine it, even in areas where we might hope we had better information. Now, the international community are very interested in this. This is a picture from the International Hydrographic Organization. They stood up a working group on crowdsourced bathymetry a number of years ago now. This is their model for how they like it to work. The archive is DCE, is actually run by NOAA on behalf of the IHO. It's in Boulder, Colorado. The idea is that they have trusted nodes, so they have a limited number of people that talk to them directly. The trusted nodes talk to the ships provide the data to trusted nodes, they aggregate it, package it up, make sure it's all good, and then send them off to the archive. And as part of this, they deal with a lot of the big problems for us. And that's one of the reasons why we want to work with them and have them deal with these big problems so that we don't have to. There's a surprising amount of geopolitical concern, even over this data. The IHO sent out a circular letter, that's how it talks to its member states, and asked them, if somebody was to collect volunteer data in your area and made it available to the public, is that okay? Please respond. The areas in green said, yeah, sure, no problem. The areas in yellow said, well, okay, but. The areas in red did not respond or said no. Some said, oh, hell no. And so there's actually quite a lot of complexity here. The archive takes care of a lot of that for us because they run geospatial filters on the data. So you send them all the data you want, they'll work out what the current state of affairs is and package it up so that you only can get the stuff that you want to do. And I would much rather they did it than me, because if you think about the complexity of places like Bay of Bengal, for example, East China Sea, even the Baltic, there's a lot of complexity there that you just don't want to have to deal with, working out what you can get, what you can get. So they have put together also tools for member states to say, if we said to you, yes, you can do it, but we want to see it before you do, they've also built tools to allow the member states to qualify the data and pass it on. There's a lot of complexity there. There's a lot of political complexity there as well as technical complexity. I'd much rather they did it rather than me. So what that means is when we start to think about how do we collect this data, where do we get it from, what do we do with it, this is the obvious endpoint. We could collect all the data ourselves and deal with all of this, or we can make sure we grease the skids so the data always goes into the archive. They take care of that complexity for us. And then we, after they've washed the data, we pull it out the other side and start doing something useful with it. I got involved in this by accident. The chair of the working group called me up one day and said to me, if we want to make a recommendation to anybody who wants to collect data, what data logger would we recommend to them? And like any good statistician, I said, well, it depends. And so we went out and we bought a bunch. And then Dan Torriello and I put them on boat and ran up and down the harbour and looked at them in terms of the complexity and so on. Very few of them came with any software support. All of them were expensive, $250 each. Now, $250 for something that goes on a boat is not really expensive. Does anybody own the boat? Show of hands. Boat owners will tell you boats are a black hole in the water into which you pour money. Right? So, $250 is not that much. But if we're going to go to somewhere like Kiribati, Palau, or places like that, where we're going to say, to really be effective, you need data density. To get data density, you need lots of observers. And every one that we want you to buy is $250 each. There's a limit to how you can scale. Instead, we need to be able to say to them, here's a logger, it costs $10, go out, have fun, scale. Scale is how you get something good. So like any halfway decent engineer, having looked at all of these and made a recommendation, we recommended this one, which sadly you can't get anymore, and that one, which you can. I looked at them and said, there can't be that much in them. Why are they so expensive? Let's have a look. And I took one apart and looked at it and went, there's got to be a better way to do this. Because none of these come with data infrastructure. They'll collect your data for you, but once you've got it, you're on your own. And if I'm going to go to a country where they are resource strapped anyway and say to them, well, here's your data logger, but okay, let's see, you have to get it off it, and then you have to use this parsing script, you have to do that, and you have to do this, and you have to do it. I had enough time collecting data to start with. That's not going to work. So like any good engineer, I then said, well, there's got to be a simpler way for this. Okay, what's our mission statement here? And this was it to start with. I think we learned a little bit away from that, just a little bit mission creep. But the basic idea was to say, what is the minimum cost, minimum functionality system we could put together for collecting volunteer data like this? And by system, I mean end-to-end system. Has to include everything. Hardware, processing software, upload, analysis, everything. And the whole project fell out from this. So during COVID, I worked out some general design principles. We wanted to be modular. We wanted to be independent so it could stand on its own. We wanted to be as simple to use as possible because the more we ask of the observers, the more we ask the volunteers, the less likely it is we're going to get any data. And it has to be cost effective. It has to be cheap enough we can just give it away. That doesn't mean that we give it away. It means that it's cheap enough we can go to a philanthropic organization and say, hey, would you mind to give them to those people for them to collect data for you? And we might sell some. But the goal is, generically, trusted node in a box. We want to provide everything it would take to stand up one of those trusted nodes that can talk directly to the archive, aggregate data, and do it. Which means that if you are a local marina, for example, you can do this. There's no excuse. We'll give you everything, right? Software, hardware, cloud processing, the whole thing. We'll tell you how to set it up. We'll show you how to do it. And that gives, I think of it as being back to my Calvinist upbringing in Scotland. There's no excuse. You can't say you can't do it. Everything's there. That's the goal. So in terms of design principles, it's mostly useful at scale. That means we have to get to scale. That means it has to be inexpensive. And we have to provide everything you need to get to scale. We need to be consistent. When we talk to the archive, we only want to talk to the archive in one way. If everybody has to set up their own transit to the archive and they talk to the archive differently every time, that's going to kill the archive. We can't do that. We want it to be as simple as possible for the reasons I just outlined. We want them to own their own data. There are organizations where they will do this for you and do the data processing for you. And for a fee, obviously. But there are communities where this happens, that owning their data is really important to them. One particular example of that is First Nations in Canada, where there's a very, very complex relationship between the federal government and the First Nations about ownership of data and rights and that sort of thing. Again, something we don't want to get into. So what we want to do is set it up so that they can contribute all of their data. They don't have to. They own their own data. It's theirs. They collected it. They were. If they want to contribute it, we make that as simple as possible. They don't have to. And to get to scale, we have to think about bottlenecks. If you have one company or one organization and they want to collect all the data in the world, that's a really big commitment. They have to be able to scale really fast to do that if they want to do it well. As an alternative, if we can set everybody up to collect their own data, but we do it so that we always are consistent with how we talk to the archive, then we don't have to have an organization doing everything. You can own it yourself, and you grow by federation. So each thing is independent, but they all use the same interfaces to talk to the archives. The data always goes to the archive in the same way. Everything moves smoothly, hopefully. And that means that we don't have any individual that's going to be a bottleneck in scaling. Everybody pays a little bit. Nobody pays a lot. And that's the deal. So this is kind of what we came up with. This is this big picture version of it. We collect data over here with either our own logger or somebody else's. We have a software layer that does pickup from the device. I'll show you how we do that in a second. It goes into a data processing system that's in the cloud, which means that you don't have to have your own machine set up, whatever you're collecting, you can have to do that. In fact, there are options, there is opportunity rather, to do this software as a service if somebody wanted to host it on people's behalfs. And then we have a smooth upload into the archive using a mechanism we've already pre-cleared with the archive so that they know exactly how the data is going to get to them as well. It makes them happy too. And on the front of it, although you can manipulate all of this directly with the tools that Amazon provide, other cloud providers are available, you want to put a small interface over the top so that people who are not technically minded or as technically minded can do this. So how do we put it together? Well, the hardware is actually relatively simple, and the goal is to try and make it as simple as possible. Hardware is hard. It's expensive. So what the goal here is to make something that's as simple as possible in terms of its hardware and make it smart through the software. So this is the base design. You have a computer in the center. It's actually a microcontroller, although it's a remarkably powerful microcontroller. It talks to an SD card, just a conventional SD card. For memory storage, we have a tiny little motion sensor on it. Don't think INS POSMV scale. We think about drop detector for your phone. We have one interface that talks to NEMA 183 on that side. We have one interface that talks to NEMA 2000 on this side, because you can get both varieties of different boats. We don't want to have two different loggers. And you have a power system that just tries to keep things afloat. Power systems on boats can be a little bit ragged. The smaller the boat, the worse it can become. So we have something that smooths out the power, manages it properly, and gives us just a little bit of emergency power. So if the power cuts out for a second, we don't stop. The early versions we did, I went back to the archive and found the pictures, were relatively crude. This was at the time at the start of the COVID pandemic where you just could not get anything. Everything was out of stock, everything was taking weeks to arrive and so on. So we made a very basic version just to sketch out how it would work. And then we did a sort of preliminary version and just put together modules to put it all together, just to see how simple could we keep it and still have something that's functional. And it's actually it's not too bad. So those of you who don't look at circuit diagrams, don't panic. The point of this is that the entirety of the design for the hardware goes onto two A4 sheets. That's one of them. And this one is predominantly power system on the top and NEMA 183 interface on the bottom here. So it's a relatively simple design. What that means is that when we make them, so I didn't have a banana for scale. Here's the scale version of it. This is what it looks like. It's not quite the same board. That one's a current generation. This is a slightly older generation. We can make them if you make them in bulk, you probably get it down to about $10 each. So you 3D print the box, you put on the connector, which is by far the most expensive single thing in the system. And the whole thing in a box with an SD card ready to go is about $25. You can make these at scale cheaply. There's nothing on it that's particularly complex. There's nothing on it that's particularly unusual. They're really straightforward to make. And that's important if we're going to have other people make them. Because that's the goal. I don't want to make these. I don't want to be in the hardware business. I would much rather somebody else made them on my behalf. So one of the things we do with this project is that everything is open source, including the hardware. And so we provide on the website, which I'll show you the QR code for in a bit, everything that you need to know in order to be able to make these. In fact, we put on the documents we use to make them, we put on the website after we made our first batch and demonstrated that they're actually working. So you know that if you download them from there and you send them to the fab and have them built, you know they work because we built them already and we know they work. For software interface, we are taking advantage of the supercomputer in your pocket. Remarkably, although the microprocessor on this thing here costs $4. It'll actually run its own Wi-Fi network and its own web server, which is remarkable to me. And what that means is that on the board here, we can put everything that it needs to send you for your browser to turn into the operator console for this device. So it sends you the JavaScript, and your browser runs the JavaScript to run the interface. Because believe it or not, the phone in your pocket is dramatically more powerful than this. What that means is that on your laptop, you can hook up to the Wi-Fi and can control it on your tablet or even on your phone. It's a little bit fiddly on your phone if you have a small phone, but you can do it certainly. And not only can you deploy them, you can configure them and you can monitor them, get them status and so on. So it means that we don't have to have an interface. We can just stick it in a box. This box mounts to the bulkhead. You plug it into the network. It just comes up, starts logging, pull out your phone, you talk to it. This is what the current generation looks like. Pretty straightforward, some optional functionality up here. We have a current real-time status, so it tells you, how long it's been alive, what the input voltage is, some other, how much data you have in your system. For quality of life for people who are installing these, it also provides you information on what version it's running and other things that are going on in the system. If you've ever tried to do remote support for something like this, you will thank me later. Because what it means is that if one of your observers is having a problem, you can say to them, go to the system, here's how you hook up the Wi-Fi, which everybody knows how to do now. Go to this page, tell me, make a screen capture, send it to me. And that tells you how long it's been running, what its voltage is, the version numbers. It tells you the last data it saw on all of its interfaces. So you know that it's collecting data, and it collected recent data. The time's there, 0 seconds, 1 second. That's time since I last saw this message. So you get a good idea of what's happening in the system. You are actually collecting data. I can't tell you how many times we've dealt with people where they've sent us loggers, and they said, not our loggers, other people's loggers, and said, well, it was on the boat for 6 months, and it went to Antarctica, and we went to this brilliant place there's never been any data for, and then we brought it back, and there was no depths. Didn't you think to check that? There was no way to check. And also, you can now get updated statistics. You can download the entire catalog of files that are sitting on your system, and you can wrap them all up in a zip file and download the whole lot in one chunk. Or you can actually download them individually. Each of the files that shows up here with its checksum, so you know it's being transferred properly, these are actually hyperlinks. You click on one thing, download it to your phone, using the standard mechanisms that you have on your browser end. We also just added, I never thought we'd do this, but we were asked for it again and again. We added an automatic upload method as well. This thing, if it comes on by itself, it will make its own wireless network for you. But if you want to, you can hook it up to somebody else's wireless network. If that wireless network has internet connectivity, for example, on the Gulf Surveyor, it will just then start sending data. The way it does it is a two-part loop. So this side on the top side on the logger, bottom side in the cloud in the server. It sits here and waits every 30 minutes. It makes a status message. It sends to the server. If it gets a response, it knows it's connected and the server's listening. And then it goes into its transmit loop and it just sends data for as long as it can, up to 10 seconds. And then it goes back to collecting data again. Next 30 minutes, it does it again. Which means that at the server, you get a heartbeat to say, hey, that device is on, it's still working. And you get the latest status information so you know it's still collecting depths, which is important. And then when we're doing the upload cycle, you get to revalidate the checksum once the file is transferred and send back a receipt that says, yes, I heard you. At which point the logger can then delete that file off the logger. So the logger never get full, they never run out of space because they're always uploading, but they never delete from the logger until they get a response back to say, yes, I heard you, here's what I heard.
Brian, can it collect when it's transmitting?
No, which is why it only does it every 30 minutes. Yeah, I have to keep reminding people, not a computer, microcontroller. right? There's a very limited amount of power in here. I mean, the entire memory on the system, once it boots, once we're running, the entire available memory is 380 kilobytes. We have to be very careful about what we run because there's only a limited amount of capacity. In the cloud, it looks like this. Again, if you don't do cloud, don't worry, don't panic. It's basically a left to right flow. Data arrives over here, comes up, gets uploaded, it's converted into the right format. We do metadata validation, it goes out to the archive here. The bit at the top is just monitoring to make sure that we know what's going on, how many files we have, provide the interface, keep track of what's in the system. The way this is designed is trying to be as easily separable as possible. These bits in the middle here are events. So that when something happens, an event is issued, and anybody who's interested in it can listen to the event and then do other processing. So right now, when this new data arrives, it automatically triggers the file conversion. But if you wanted to do something else, you can just listen to the same event and do it. So on. And that's what means, what I said before, if you want to contribute your software, your data, we make it easy. If you don't have to. All you would do is just turn off that chunk there if you didn't want to upload it. And then when the data is validated and that message comes out, you can alert the user that something has happened, but you don't have to send it out if you don't want to. And it doesn't change the behavior of the rest of the system. It's designed to do that. We also make very basic outputs. Feedback to the end user is really important. It doesn't have to be terribly fancy, but you have to have something. And so we make some version of this. We could probably make better versions of this, but even this is enough to say to people, hey, remember that file you sent us or that logger we gave you? Well, here's what you did. And that handing something back is what keeps your crowd engaged. That's what we hear feedback from people that are doing this in the field. We also provide user interfaces, the prototype version of the user interface. You get a list of the files that are there, you can manipulate them, you get a list of all details there, and there's a dashboard and some geographic. Again, very basic. You can go to people, companies who will do much more sophisticated dashboards than this, much more, for a fee. But if you want to own your own data, you have to have something of this, even if it's simple. It doesn't matter if it's terribly complicated, we get better over time. Try and keep it as simple as we can. The very first trial of this system, talk about going to extremes, we took it out on the Healy with us when we went through the Northwest Passage in 2021. So I turned it on there, and then we logged all the way through the Northwest Passage until we got heading into Nuuk in Greenland and turned it off there. And that data is actually in the archive at DCDB. This is the official NOAA viewer for DCDB. The big success for us though was last year when the Canadian Hydrographic Service built their own loggers, configured their own loggers, installed them, ran them in the field, and processed the data and gave it to the archive themselves. We had nothing to do with it. We helped, we advised, but we had nothing to do with the collection. So they were collecting on small boats, and they're running surveys like this. They didn't like our box. Very aggrieved about it. They wanted a Canadian-made box. It actually is Canadian-made. Called an Anuth. It's actually IP67 certified, which means it's watertight. And for small boats, that's really important. You can see the sort of installations that they got themselves into, and they have their own processing scheme that they use for doing this. That was a very exciting milestone for us. We've also used it to help with the Crowdsourced Bathymetry tools, which was Monday last week was the second workshop on tools. We installed one, as you can see, on the Gulf Surveyor. I wasn't there that day. People that were there talked Captain Matt into drawing fishes on the floor. I spoke to him afterwards just to thank him, and he said, should have done a monster. We have created a monster. So with all this effort of collecting data by others as well as us, this is what the archive looked at like a couple of weeks ago. You can see they're actually doing not too bad in collecting a whole bunch of data, even here. So the entire data set is a little over 2 billion observations. Even here, just in the area around Great Bay and Portsmouth, I'm not sure who's doing the collecting, but somebody's doing the collecting. We have 300,000 points just in the last couple of years, because we were none 2 years ago. So it's happening very quickly. What it means then, though, is we have to think about processing. What do we do with it afterwards? Now, The good news is that a lot of people, smart people working on it. The bad news is there isn't an agreement about what it should be yet. So these are three different workflows. There's one here from NOAA. Listening or in the crowd. This is one that was developed at NOAA. This is one that DCDB put together. This is one that was put together by a company who's sadly no longer in business, or startup, didn't quite make it. But what it means is that we're early enough in the stage that nobody really knows yet what the right method should be for doing the processing. And so we have to think about how we put that together. And even simple things that you take for granted in a big survey system like we normally use are not obvious here. Those of you who remember the bad old days of dealing with survey systems where survey systems were hooked up with serial wires and sticky tape and spit will remember the problem of time referencing. Now you plug into the 1PPS and all your problems go away, right? That didn't used to be the case. On these little loggers, it's still not the case. What you get when you log things is elapsed time generally since the logger was turned on. And every time you get a message, you can tag it with what you think the elapsed time is, including time. That may bend your head a little. It did mine when I first had to deal with it. We get messages that tell us what the GNSS time is, possibly corrected for actual UTC time rather than GNSS time. But we don't know when that was actually valid. We think it was valid within the last second because we should get one per second. But that's really as much as we know. We don't know what the latency was in sending it to us or how long it's been sitting in the queue on the network. We do know when we received it. And the same is true for positions and for depth. And you can see the sort of, for illustration purposes, only on the top there. What we have to do is try and time reference all of the data. So we have to build a lookup table from this to say, to map from lifetime to actual lifetime. And then we go to the depths and we say, okay, at this time here, which was the last time, what was our actual time? And then where were we when we were at that time? And sort of try and match up all the data. So there's complexity in that is problematic. And if you get it wrong, it can easily be a big problem for you. Some of you, I'm sure, will remember dealing with backscatter 5 or 6 years ago. But exactly the same file, processed through multiple different processing chains, gave dramatically different results. Not a little bit different results, but massively different results. We are in danger of doing the same thing here. If we have multiple divergent processing paths, each organization doing their own and nobody talking about what they're doing, that's going to be a problem for us, particularly for people who are going to rely on the data or want to somehow rely on the data. How do we convince them that we're doing the right thing? Consistency is really important. One of the big questions about this sort of data is how much I can trust it. One of the ways you can get better at trusting things is having really good metadata for describing what's going on. So construction and maintenance of metadata is a thing in crowdsourced bathymetry. It's actually maybe even better defined in crowdsourced than it is elsewhere, believe it or not. But we have to have some way of making sure we hold on to it and we update it and we make it stay up to date and valid. We also want to send this data to an archive. One of the big problems with sending data to the archive is that if you send the data to the archive but not the software, you have to ask yourself if you actually have an archive or not. I can physically still read the data. I can take it off the tape. I can make it back into individual bits and bytes. I can turn it into electrons again. But if I don't understand the format or I don't know what was done to it, do I actually still have the data? NOAA went back to the survey archive in about 2010, roughly, and said, we'd like to get all the backscatter back out because we now know what we're doing with backscatter. Now, we've been saving it for a really long time. Please give us our backscatter back. The hit rate was about 50%. And that's for modern data. So one of the things that I'm really interested in is to say, if we have a system where you can also archive your workflow in a machine readable format, does that give us a way of getting around that barrier a little bit so we can best practice say, here's your data, And here's the machine readable version of what I did to it. Hold that with the archive so it becomes part of the documentation. And if we have a standard processing method, then it's works if you go on board. I can say to them, if you're not sure what you want to do with your data, well, here's an example. Here's the base example. Start. That's a big thing for us. So we have a separate project, QR code here for the repository, which is called OpenVBI. And the idea is trying to capture together what we believe to be best practice. Maybe not most efficient, that's okay, but best practice for how we deal with this data, what the algorithms look like, what the technical details are of how we do the processing. And you can see the list of all the things that it does here. It has lots of input adapters for the various different loggers that we use and for the stuff that we get from the archive. We just added GeoPackage just last week. We have core functionality to deal with some of the complexity that I was just talking about. We have corrections. The ones in green are on the skids ready to go. They're not quite installed yet. They're next. We have water levels corrected through zone tides. This FES model will do water level corrections globally. Uncertainty, estimation, product creation, they're on skids ready to go, workflow management, and so on and so forth. And the goal here is that we don't necessarily expect everything here to be as whizzy as you might want it, but at least it'll give you the right answer. And as a community, hopefully we can agree, when we say process, what we mean is that. Maybe a faster version of that, but that. And by way of example, again, if you don't code, don't panic. This is what a full workflow looks like. It is 41 lines, including comments and includes. It loads data from a raw binary file, generates observations, which is one command, adds metadata, which is one command. The majority of it is setting up a filter by depth range and by time range, which is this bit, and its application, which is that line there. Correct for water level, using those tides, wide tide data, gets straight from the API, and then writes it out in the appropriate format to go to the archive. So not an awful lot of code. But the fact that you can write it down and you can get it on one screen means that when I say I've processed data, I can send you that as well. I can say, for OpenVBI version 1.1, and that's what I did to my data that I just sent to you. That's your archive. The metadata is pretty extensive. Every time we apply an algorithm, it reports what the algorithm was, when it was applied, where it came from, versions, parameters, and so on. And so you get, hopefully, really good data.
Right, if I could
Yeah.
just ask on the last one, the filter, the way that's the filter, is that something the user inputs or?
Yeah. This is just arbitrary to demonstrate what sort of things that it can do. You don't have to, but you can. I'll show you an example in a second where we have a GUI for doing this, but you can do that if you want to.
It's not extracting from a chart or something.
No. It's completely arbitrary. The point is to demonstrate the functionality rather than say that you might do this in Anchor. Although you might say report nothing below 2 meters, report nothing over 500 meters. Another one of the big issues with this, which I didn't mention before, but I should have, is that most echo sounders on ships that are going to be doing this have a depth range that tops out at maybe 100 meters. So in the deep water, you're going to get nothing. That's okay. There's a node constraint in the system. That metadata is very well defined. This is a project now run on behalf of DCDB, but it was built by my partner in crime over here, which is a JSON schema that allows you to validate metadata. So you can, every time you send metadata to the archive, one of the things we do is make sure you're sending something that's actually valid, isn't going to break the archive. And having all that functionality there allows us to build simpler tools for people who aren't as familiar with walking around in the internals of Python, so that we can put a workflow behind here and then feed the inputs for the workflow, what format it is, what we want to write it as, which message we want to use for depth, minimum, maximum depth, and so on. Hit the button, and it will then scan a directory, pull out all the files that match the specification, process each one and give you updates on it, give you some statistics of what's going on, and give you a list of what worked and what didn't reply. So in terms of data flow management, if you're processing locally, typically when you have a logger that's not one of our loggers, then you have the functionality there. also allows us to do kind of cool things, which is because we have the schema that describes how the metadata is built, we can actually read the schema and build the GUI from it. This is code that Brian put together. You actually reads the JSON schema, which is itself JSON, which feels a little circular to me. And then we build this GUI automatically all the way down to here. And then we have a bit to export it. We can do pre-flight checks without running the full validator. We can validate the entire thing and export as well. And what that means is that every time the schema changes, the GUI automatically updates. We don't do anything like that, which is kind of nice. So in terms of what we do next, there's some really interesting things going on here. I think we've got to a pretty good stage. The functionality in OpenVBI is such that we're almost at the stage where we might just move all of the work that we're doing in the WIBL project. Instead of doing our own processing, we'll just add OpenVBI as a dependence and use it instead. We seeded it with the majority of what we had done anyway, so it's not that much different. But the interesting part would be to do it in the large. This is a graphic sent to me by Anthony Clem. I hope he's listening. If you are, thank you, Anthony. This is an internal NOAA webmap. Anthony processes all the data in the archive every so often to try and get an idea of how good it is, where the coverage is, where we might go to surveys, where we might use the information and so on. This is the East Coast around Chesapeake. It's in chunks. And that chunk is, if I load anything more than that, my machine blows up. But this runs when Anthony has time, and it means that it sucks the data out of the archive to his local machine. And it means his machine sits there and goes for some time, and he can't use it. And so one of the things we're really interested in doing is, could we make this happen all the time and everywhere? Could we take what he's already done, and some of the bits that we've done it ourselves, package that up so we can then launch it as a process that will do a chunk. And then we set it up with a work queue, and it says, here's the work queue for the entirety of the US. When you have time, pull off the first bit, do that. If you don't get it finished, put it on the bad list, take the next one, keep working. What that let us do is look at things like, what's the complexity of building that system? What's the cost to run that system in the cloud? The cloud's not free, right? It's cheap sometimes, but not free. Can we structure it so that we can take advantage of what's called spot pricing, where we can say, when nobody else is using the computer, I can get that computer in the cloud at knockdown price, with the caveat that with 60 seconds or less notice, I might get kicked off. Well, that's okay for me. If I get kicked off, I just put it back on the work queue and I go back and get it later. So can I optimize my costs in doing that sort of structure? And can we have something that's continuously up to date that everybody can see? What would it take to do that? It's a really interesting problem. Now, it teaches a lot about working in the cloud and this sort of question. There's multiple projects that have similar structure that we could use this as a basis for. The other thing is we've done some work previously talking about credibility of observers. If I have observers that are volunteers, how do I know which ones I can trust? Some of them, this is Uncle Jim's basketball, right? After Uncle Jim's had a couple of years. This is high-res hydrographic survey done by an authoritative source. Everything falls somewhere in that. If I can estimate where they fall in that gives me a way of saying something useful about how much I can trust that person who's making the observations, and therefore how much I can trust the observations, there's a transitive property there, after they're made. One of the things that lets me do, if I estimate what the reputation is, that's the blue line there, the red is the uncertainty in that reputation, is I can then use it as a way of saying, how much data do I need to have, how many observations do I need to have to convince myself that there really is a difference in the archive? The archive was right when it was taken. It's not a guarantee it's right now. How long should my data live in my archive? If I have a reputation that I'm willing to say anything above that I'm happy to have, then depending on whether I have an authoritative observer, in which case a few observations are enough, or a non-authoritative observer, in which case more observations are required to really convince me that there really is a difference there. I can then just change my level of risk to determine how much evidence I need to convince myself to go change the archive. And that could be, don't tell anybody about that data anymore, hold on to it, we don't think it's reliable enough anymore, or we should go survey there. So there's really interesting applications for this sort of thing, if we can do it. The key to doing this, we have the basic theory for it, we've shown examples of it, we've written our papers. But the key to doing it is to do it in large. Can we do it everywhere? Can we make it into something useful rather than a mathematical curiosity? It's based on how you score chess matches. It's kind of fun. We've also done another project looking at better quality observers. Trust the hardware, not the observer. This is a system that Sarah helped build, worked on the geodetic part of it with us, where you have a receiver box which has in it a GNSS receiver. Now, in real time, don't think about it, but in post, you can correct for the offsets such that when you have a ship, you can measure the height here on the receiver, you can measure the depth here on the transducer. The bit you don't know is the piece in between. You can get the accuracies in this down good enough, about this size of your fist, roughly, that you can estimate what those offsets are automatically. So you auto-calibrate. So you have a system which is, yes, a bit more expensive, but can auto-calibrate so that its estimates of what the offset are match what the LiDAR survey are within a few centimeters. And if we can do that, then once it's calibrated, we can resolve depths from that boat on the ellipsoid, and we don't have to worry about water level corrections wherever we happen to be. And these systems then become portable calibration units that calibrate other sensors as they go. Everywhere they stop, they put down another calibration point. We also did an experiment with a really interesting project with graduate students who now works at Marine Chart Division, Casey O'Heron, where we buzzed the Gulf Surveyor with a LiDAR-equipped drone, and then we buzzed it with a very cheap quadcopter, and demonstrated with the quadcopter we could build the orthomosaic photograph and then measure the offsets of it and get it within a couple of centimeters of what the LiDAR survey told us it was, which is kind of cool. So you can resolve horizontal of anything you can see, you can resolve vertical automatically, you make much better observers. What we'd love to do is to be able to do that reliably. The problem is, can't get that. So our plan is to build the hall, because in the meantime, the technology cost for the bit that does that piece has come down dramatically. This is a module you can get from U-Blocks. They've been around for a little while. They're now about $150 in bulk. And that thing will, in real time, give you a decent estimate of position. In post, it should give you a positioning estimate in all three axes about the size of your fist under good conditions. If we have it as a daughter board, we think we should be able to put that daughter board, plug it into the main board, and use the original logger that's $10 a pop for the data logger piece. And in post, be able to do exactly what we were doing, I was just talking about, with an entire data system, logger, board, logger, daughter board, memory card, cable, antenna. Target price $500. So that's not the $10 here, have a new one, scalability. But it's a great deal more scalable than other systems that we can get. And we don't need as many of these. We need a few of these to give us the calibration points, and all the other observers can be the low-cost observers instead. Those boards came out of the fab on Wednesday. They should be here either this week or early next week, hopefully. We'll get a chance to play with it. We'll do the initial smoke test, make sure we don't let out a bunch of smoke. And then if we get to, we'll learn a lot about how to make them work for dev as part of it. So that's what we've been doing in our spare time when we're having fun. Here's the website about the whole project. There's links to everything else you want to do. That's this QR code. It's just wibl.ccom.nh.edu if you didn't want to go and get it directly. This is all open source. It's all in GitHub. That's the QR code for GitHub repository if you want to have that. We're running out of time. Thank you. Questions? Tom first, then Sam. And then
Brian, I asked you about this a while ago. So when we have things like ferries that just go back and forth across the waterway, the depth information we're getting is probably the same every time and not super useful. But if they can collect temperature or even ideally salinity, that's a moving water mass. So we're getting new data every time. And that would be super helpful for the people that are doing these hydrodynamic models.
Yep.
And I think you said that we could pull temperature data from a lot of sonar systems.
yeah.
I don't know if it's feasible to get a cheap salinity sensor and have that running. as well.
Salinity sensor, I don't know so much, but temperature, yeah. Most, at least that I've seen, most recreational sonars have a little thermistor built into them because mostly they're designed for fishermen. And knowing the temperature of the water is whether the fish are going to bite, right? And so they have some temperature sensor. If they have, it typically comes out on the same data buses, so we get it on the data bus for free. If they had a salinity sensor and it was generating data on the data bus, again, we get that for free. All that's wrapped into the data. Now, there's nowhere currently for it to go in the archive. But one of the good advantages of the archive system now, the structure of the metadata used to be controlled through the IHO, which means that it can only change very slowly. As of last year, that got pulled out KCDV links after that directly. So our ability to make changes to that quickly, to provide a place for this, has dramatically improved the last year. So it's certainly something we could do if we've got somebody willing to do it and we can find a nice sense. Yeah. So,
Just in addition to that, if you have the rule that GNSS received, we can also reconstruct the geoid. It's a nice little extra bonus.
yeah. And you're recording the data anyway, so you get it free.
If I were a boat owner, wishful thinking, what would be the minimal set of steps that I would need to take to become an effective WIBL operator?
So what you would do is you would talk to somebody who's a trusted node. So the easiest one to get to is the International Seakeeper Society. They will give you one of these that's pre-configured. They'll probably ask you about your boat, where are things if you have that information. Into the logger, you can write the metadata chunk that's specific to the boat into the logger, so it goes into every data file. So when you send it for processing, if the processing sees it, it pulls it out and uses it directly. That's by far the most efficient. If your system is on NEMA 2000, the complexity is you put this on the boat, you put a connector on there, and you walk away. That's it. That's all it takes. It will start up, it'll come up on its own Wi-Fi. You can then use your phone to talk to it if you want to see what's going on. If you have your own Wi-Fi, you want it to auto-update, you can do that too. All the documentation on how to do that's in the wiki. So it's pretty straightforward to do. You have to have a system that generates either NEMA 183 or NEMA 2000. That's pretty much it.
A comment and a question. Your comment is, it seems like, yes, near harbors and along the coast, a lot of boats, right?
Yeah.
But it seems like that's where you want updates all the time. So it seems like a continuous, once you get the quality where you want it, a continuous sampling of that would be extremely useful for looking at changes after storms, habitat changes, whatever.
Yeah, absolutely.
That's the comment, and I see you nodding your head, so that's good. The question is, if I were, you mentioned First Nations and wanting them to own the data so they can choose whether to give it to you.
That was one example. There are other examples.
Right. The question is, so attribution follows through in the metadata, because it seems like attribution will be important to entity.
Yeah, so the metadata has in it a collector name, a unique ID for the device doing the collection. So each one of these has a unique ID that's burned into the metadata that you use for it. You can change it, but it's stored in the metadata on the logger. You can also store a name. You don't have to. A lot of people want to be anonymous. That's fine. And so you can. It's not etched into rocks. You can change it, but by default, that metadata follows the file all the way into the archive and comes out the other side. There's also a space for a data license in it. By default, we set that to Creative Commons 0, version 1. But you can, it's part of the metadata. You can change that if you want. We try to encourage people to use CC0 when we can, because it makes the data most flexible for remixing afterwards. But it's up to you. It's a choice of the collector.
I'm glad you brought up the issue of credibility, because I was amazed when you said that 300 and something thousand crowdsourced soundings reflected locally. But I was even more surprised when you said, but we have no idea who collected them.
That's just because I haven't looked at the archive.
Oh, okay. All right. And the metadata, I can.
But the metadata will have that information, I just haven't looked.
Yeah, so it's something you have to track because.
I should have said,
Yeah.
I don't know who they are.
Okay.
Now, here's an interesting thing though that I heard just last week. The CHS, I hope you don't mind me telling you. The CHS went back and reanalyzed the data they're collecting as part of their community hydrography program. So this is a program where they go to distant parts in Canada where they know they're never going to get to themselves. And they say instead, okay, so you're never going to get there. If you want uploaded data from your charts, you're going to have to collect it yourself. We'll help you collect it, but you need to collect it. Give it to us, we'll process it. Yeah. And they went back and they analysed the data and looked at corrections and everything else. They're careful about how they do the corrections. So it's kind of the higher end of volunteer collection. They demonstrated that the accuracy of that data was about the same as the accuracy that they were collecting themselves circa 1995. And that was good enough to put on the chart then. That's pretty impressive, really, when you think about it. So this is not garbage data. It's not something where you have to put a lot of effort into. If you're willing to put in the effort in terms of the corrections and making sure people do the right thing, you get some pretty nice data of volunteer collectors. You'll always have some super collectors who do the right thing, and you'll have a few others that don't.
There's also going to be an issue that there's going to be some set of people who just don't want something on their vessel that's being tracked. Things like that. And then, but I think you have to just dismiss that.
Well, it's a question. So there's an interesting thing. We've always assumed that fishermen were not going to be involved because they don't want people to know where they're going to fish. That's really not true. I got stopped in the corridor earlier today. They were I want to have a logger. I'm working with the school. They want to collect some data. They teach people how to build boats. We want to collect some data when they have the boats out in the water. I think that's perfect. Here's a logger. Have fun. I'll show you how to work it. Stop me in the corridor to see. Earlier today, he said to me, I showed it to one of the lobstermen. Now they want 3. I don't have 3 to give you. Everyone I've made, we must have made about 60 by now. Every time I make them, people show up saying, I have them. And unfortunately, the university has no way to charge for them. We just have to give them away. And the thing is, if we give them away, we get feedback. That's the value. So maybe for the right fishermen, it's actually okay. Some people won't. And one of the things we've talked about is, could we do geofencing on the logger so that the logger knows where it is reliably enough that if it goes to an area, say, when you're getting towards where you're going to do fishing, it just stops recording from there and then records when you come back in or something.
Or just give them an on-off switch.
Well, the problem with an on-off switch, yes, I agree, you could. The problem with an on-off switch is who remembers to turn it back on. So first time it gets turned off, it'll probably just stay off. And that's a problem. So, there are things like that. I mean, if it's uploading, we could tell that it had not uploaded for a while. We can call them and say, hey, did you turn that off? Oh, yeah, I forgot. But if we don't have to do that, then it would be better, I think. Again, though, what it comes down to is there's only so much processing power in that microcontroller. And the more I ask it to do, the slower its loop goes, so the harder time it has recording the data reliably. So we have to be careful about what we promise to do as companies.
You had mentioned that the archive can handle all of the policy pistols.
Yes.
Who are the people that are handling that? Do they have protections if the state had an issue with where data was collected?
Yeah, so the way this works is that the archive is technically owned by the International Hydrographic Organization. It's run on their behalf by NOAA at the data center in Boulder. And the IHO works by consensus. So the way, when they wanted to do this, they went to all of the member states and said, we have this proposal, we have this plan for how we're going to do this. Do you agree that's okay to do that in your territorial waters, in your area of jurisdiction? And that's the map that I showed you. Some places they said yes, other places they said no. Some places, most places just went, either said, no, okay, but, or they just didn't reply. And in many cases, that's just places where they just don't have anybody who's paying attention to it because they have many other things on their mind. So really what's happening is that it's based on what the member states themselves accept, whether they accept it or not, what the caveats are. And the DCDB is just implementing that process. The IHO itself is a international non-governmental agency, right? Which actually gives them stronger protections than you might believe. They tell me, I don't know, I really believe it, but they tell me they can't be sued. And for data like this, that can be actually really important. If I take data from the archive and rely on it to sail my boat and I run aground, who's responsible? And you say, well, you're responsible because you took the data. It wasn't officially blessed by a hydrographic organization. But then, is that really true? We probably won't know until somebody does, which is a little scary, which is a really good reason for why they should do it, because they have really good lawyers.
From the mariner's perspective, what's the, I guess, idea between say you put it on your vessel and you go somewhere in Europe or one of those areas that have the yellow zones or a red zone, like are there protections against a mariner for accidentally getting in an international incident?
Yeah. So the data, the IHO again are very specific about this for exactly this reason. Crowdsourced bathymetry data, per the IHO definition, is data collected by the mariner as part of their normal course of business. So there's a regulation, again, I'm told that there are specific exemptions for data that you collect for safe navigation. So if you're collecting it to make sure you don't run aground, you're allowed to do that anyway. The bit where it gets sticky is you then take that and you give it for somebody else to use for another purpose. And that's the thing that the member states were. So in terms of the individual collectors, probably, again, not going to be an issue for them. They're giving into the IHO. The IHO has those protections because they are, and it's the IHO that's providing the data to the public. So shouldn't ever be a problem. I know of at least one state, however, who not only said, oh, hell no, they also said, and if you have anybody that's collecting data in our waters, we want to know who. So another reason why they should do it, because they really, really much.
In terms of the hardware design, I think this is all seemed relatively industrial jelly bean, but I know some, especially larger shipping companies, might be understandably nervous about putting untested hardware on the ship. Is there any works being done to get it ship approved, or?
Yeah, so this is the you can get it approved in a couple of different ways. The one that we're pursuing at the minute is to get it NEMA certified. And there's a whole process for doing that. We did talk to the people from NEMA were here, including their Brian, do you remember who it was that was here? The president and chief officer,
executive board.
Yeah, they were here on campus anyway for a meeting at the interoperability lab, the testing point. It's also on campus. And they came by, Brian did a presentation, they came by later, we had a meeting and they said, this is something we could do is, if we became, for example, a CCOM industrial partner, our contribution could be to certify these things for you, because otherwise it can get pretty expensive. And that's kind of what we're trying to do right now. So we have had people ask us about that. In fact, Seakeepers went so far as to say we may even be able to pay for it to get these certified. So that's certainly something we want to do. You're quite right. I mean, we're asking people to connect these to a mission-critical, safety-critical system. Now, the loggers don't transmit anything. They're just sitting there quietly listening. The chances of them doing anything bad are pretty zero. But I do know of Alon, named names, which is known to interfere with autopilots. So if you hook this thing up and everything's fine for a little while, then your autopilot cuts out. Which is a problem if you're solo sailing in the middle of the night. And that one incidentally is NEMA certified. So the NEMA certification is not a guarantee of quality, but it is some guarantee. So that's what we're trying to pursue just now. And it will be, as required. Again, one of the big questions though is, if we certify our design that we build and somebody else builds them, do they have to get theirs certified too? In which case, it might actually be better for us to certify somebody else's design rather than ours. And then when people say to us, can I get certified? Well, yeah, go talk to them. It's an interesting question. Again.
What are the current working group's effort to give back to the community, like updating charts or give them a feedback of how much data they've collected or
the working group does their best to make all data available in the last year, DCDB have also put on dashboards for all the trusted nodes. The trusted nodes can get feedback on what they're collecting and how much is being collected. All the data is available for public download. The archive, though, say we're an archive, we're not a data processing shop. And they just don't have the people to do the data processing and data wrangling and all that sort of things. Which is why that processing in the large project that we have in collaboration with the archive and with NOAA is interesting to me as well. Our research goals are really about learning about, what does it take to do this in the large? What are the bottlenecks? What does it cost? So that we have better answers for those when we get asked those questions about other projects too. But if we make it work, that project should demonstrate what it would take to real-time or always up-to-date, always up-to-date, the version of the output products that Anthony's currently collecting. Now, what I showed you is an internal NOAA web map. You can't see that from the outside world. You have to steer it. But if we do, we can make a web map there, which anybody can touch. And we can show how to do that. And the lessons we learn from doing it for the US, because we are constrained to do it just for the US, that's our area of responsibility, will then inform us. We can say to other countries about, okay, here's what we did. If you want to do it, here's about what it would cost. Or we could say, well, if somebody wants to pay for it, to do it for the globe, it's an international database after all. Here's what it would take to do that as well. And that's going to be really interesting. Right.
Just quickly to clarify on the certification piece, the large vessels they're not using our logger. Like, for example, Carnival Cruise Lines submits data, contributes data, but they're using the schema and the format. So that as long as you do that, it doesn't matter. How you collect it.
But they actually collect their data through other systems. And to be clear, well, we built the hardware piece because it was a fun and interesting project to do and satisfy the niche. I don't want to be in the hardware business. I would much rather the companies like Raymarine and Garmin and Johnson Outdoors and Navico that make these systems that people buy, they have everything they need already. They're getting the data, they're getting the position, they're getting the time, they're showing it on screen. They record it themselves for their own internal CSB projects. What I want them to do really is to put a button in the interface that says contribute and leave it up to the users to decide whether they can contribute their data or not. That's happened with Coastal Explorer, for example, and that's one of the biggest contributors to the 2 billion soundings that you see. So Coastal Explorer is a piece of software, is an electronic nautical charting system, not an ECDIS, ECS. And they added that. They said, well, we don't use any data for anything. Let's just add that button. All of a sudden, the entire database went. I'd love to see that in everybody else's as well. But for many of the manufacturers, they run their own closed garden. So they take the data from their users, they do some magic, and then they give it back. It's a layer that shows up in their charting system. And there's value. And so they're not interested in putting the engineer hours into adding the button that says contribute or trying to data to manage the process. Convincing them to do that, to change their mind about that, is an ongoing project. I think we're making progress, but I can't guarantee it just yet.
Have there been any lobbying for incentives to do that? Because I mean, they don't do that because they don't make money on it.
Yeah.
And it seems like that's probably what needs to happen. The actual user, it would be fun to gamify it so they can actually get unique areas, instead of going the routes.
So that's the gamification.
Exactly.
It's a really interesting question, right? We did a study when we went out and asked a whole bunch of people. We said, what would it take to convince you to collect the data in the first place, like the end user collectors? And we said, can we get you a badge from the Admiral? Can we pay you money? What do you want? And they said, give us our data. All they wanted.
Talk about OLEX. Let's talk about the.
Probably the most successful closed garden system. Yeah, exactly. So, in terms of incentives, I think the only incentive that I know of that would really work is give them their data. And that's why, even though we're making very crude output products at the minute, we can make better ones. A lot of the time we make things which are intentionally crude. For years, I can say years now, it's like 2 3 years. You notice on this board, there are no mounting holes on the board. You can't see it from back there. The only thing that's holding it in the box is that, right? And the reason for that is, at the point when we designed it in the first place, we hoped we'd never have to do these and that somebody else would make them for us. Didn't work out. But one of the reasons we didn't put mounting holes on it was because when people looked at it and went, geez, that should have some mounting holes on it. Well, theirs does. And we funnel people that way, right? You notice the new boards have mounting holes on them. When we make the outputs are relatively basic because there are people that make really good outputs and really good dashboards. As a centre, as a research centre, as Barry will tell you, we never want to compete with a commercial entity because we're cheaper than they are, more or less. So we could, but if we ever did, we get into a lot of political trouble. We don't want to. So we have a balancing point we have to be on where if nobody demonstrates that they want to do a thing, then we can do it. But if there are people who are making products, we have to be careful that we don't do something that would be considered to be, really competing with them, because most of them are industrial partners. That would be bad.
There is value to this data that they're collecting. I mean, that's data that doesn't need to be collected, and there's more value for areas that need to be collected that are further. So kind of, I don't know, just.
I absolutely agree. And I mean, I don't think they actually need to do anything. They just need to be like Rose Point.
Yeah.
Goes to the door. Leave it up to the user. And let the button that makes it. You have all data. Just add the button that makes it, let the user decide. That's all we need to do. Even that's a concept.
I think that's it. Let's thank